connection to Science Night. Please stand by.
Welcome back to another edition of the Science Night podcast. My name is James, and with me, as always, is Steffi.
Hey.
And Jason.
Hello.
Well, we've made it to the end of another year, and tonight we're closing 2023 out with a bang. We got the next big supergroup, Science Royalty, and in the second half, we have Ignition. There's a lot to cover, so let's get to it. Since we are at the end of another calendar year, we decided we're going to put together our famous top 5 list of most downloaded episodes for the year. And, instead of just reading from a list on this feed, why don't you go over to our social medias that we'll link to at the end of this episode, and you can find some actual fun stuff that I'll put together for this list. So just know, on the socials, the Twitters, the Mastodons, the Instagrams, we're going to do some top 5 stuff to round out this year. So be sure you're following us on all of the social medias. Well, it's all right. Riding around in the breeze. Well, it's all right. There's 2 things I know about the Tree of Life. It's a useful tool to organize species into smaller groups that are more closely related to each other while also showing the diversity of the natural world. And it is also a useful meeting place when you get separated from your group on a busy day at Disney's Animal Kingdom. And just like that Disney park, new stuff's getting added all the time as we discover new species. In a recent article from the journal Nature, it tells us about the discovery of a new supergroup of killer microbes patrolling water around the world. Collectively, they're called Provora and have been described as the lions of the microbial world. So we got a new thing that we discovered that's also just slightly horrifying, which is that sweet spot for a Science Night story, right?
Can we take a step back and
Yes.
talk about what the Tree of Life is? Because then that puts it in context.
Yeah, so
Thank you.
it's kind of like a hub system at Disney's Animal Kingdom.
Okay,
What
good.
they did is they carved a tree with a bunch of animals on it, and it's something that you can kind of see from every part. It's typical hub and spoke, just like Walt would have loved.
Yes, that's the human-created Tree of Life. Then there's nature's created Tree of Life, which is a little bit different.
They're both human created, Jason.
Oh.
The Tree of Life is just a diagram.
Yeah, it's true. However, what I'm trying to differentiate this from is created in any way. Not illustrated, but created, right? There's no creation here. Instead, it's,
Got it.
natural selection and evolution has created this amazing connectivity between life on this planet. And, we can trace it back to single-celled organisms. There are 3 domains of the Tree of Life, right? The trunk is made up of these 3 domains. There's bacteria, archaea, and eukaryota. Bacteria and archaea used to be sort of together. Those are the single-celled organisms, the so-called prokaryotes. Eukaryotes are multi-celled organisms, and that's where we come from, right? So we're broadly in that domain. Now there is a new domain, this supergroup, right, called Provora, that's actually divided into 2 different branches, or what we call clades. The names of these branches are the best. So they're the nibblerids, which use tooth-like structures to nibble chunks off of their prey, and there's the nebulids, which engulf their prey whole, right? These are the best names for anything ever.
Yeah.
They sound so cute and so vicious.
They do sound vicious, and they are actually vicious. It's because they prey upon other microbes within their ecosystem. And because they are so rare, they're actually kind of seen as apex predators of their own domain, right? Which is nuts to think about, right? When we think of an apex predator, we're thinking of something at the top of the food chain, usually very large. It's eating all the things that are smaller, but these are still very tiny organisms that just happen to be super predators.
With little flagella.
Right. I feel like nibblerids and nebulids are straight out of Fantastic Beasts.
Yeah. For the Nibblerids, I went straight to Futurama with Nibbler, the little pet that is actually a super intelligent alien form.
Sure.
That creates dark matter by eating things and then pooping.
Right. I love Futurama, but my
Yeah.
thoughts immediately went to Nifflers.
Oh, sure. Yeah.
Yeah.
I got to say, though, for a supergroup, normally when you put together a supergroup, like you've heard of the constituent parts of a supergroup, you know what I mean? Like, like think about like Asia. Right.
Yeah.
Asia, a really good one. Another supergroup, right? You got members of Yes, you got members of the Buggles, sort of all together. Like video did kill the radio star, right?
It sure did.
And that launched to Asia. This is a pretty esoteric conversation.
Should we go for more on the like traveling Wilburys out of the beginning?
Yeah, we should. The Traveling Wilburys, another one, right? A supergroup.
Yeah.
Also, probably the least attractive male boy band, right, that ever put together.
They picked the worst out of each one of those groups. Yep. When Tom Petty is the heartthrob, it's
right. When he is the heartbreaker, we got a problem, right?
Yeah. We always hear about like how we're like one or two, nucleotides away from a banana, or we're so like closely related to all these things, but the Provora, the Nibblerids, and the Nebulids are really different from us. They found that the difference in a certain strand of RNA of some of our genome is like 180 different nucleotides from the human genome, which is really interesting as far as they understand it right now. So this is kind of pointing that these, like, we just found them, but they've been around for a really, really, really long time, which is kind of why they're at this point of the Tree of Life, which may be like a better explanation of the Tree of Life, is it shows how closely related things are to other things by like how close the branches are. So this would be like on the opposite side of the tree from humans, right?
True.
So why now? Why is there a new branch now on the Tree of Life?
That's a good question, actually. I think a lot of it has to do with just dumb luck, right? I mean, they identified these organisms in samples that were taken from like the coral reefs of Curacao and some of the sediments in the Black and Red Seas and the Pacific and Arctic Oceans. So it just happens that we find them. We found them all of a sudden, probably because people are trying to understand why our oceans are dying, right? And the intense research that's going on ocean floors because of that was the fortuitous opportunity for these organisms to be identified. So I think that answers the why now, but it doesn't answer the question about sort of what does this all mean, right? I'm not sure we even know what this all means. It just means that, or at least at this point, there is a lot more life on this earth than we'll ever know. And it further underscores the tragedy of climate change because species are going extinct so quickly. And that has happened through time, right? That's not anything that's new. It's just the rate with which that is happening now is alarming. There's so much that we don't know about life on this planet. And if we're still just discovering even new trunks to the Tree of Life, what have we missed an opportunity to learn that might help us survive the impending challenge that is climate change?
Well, and it also kind of highlights the fact that we do know a little bit more about like deep space than deep oceans on our own planet. And not that these are in like the deepest part of the ocean. They're around coral reefs, so it's areas of the water that's easier to get to. And I think that makes the climate change extinctions even more tragic because we know so little about life in our ocean, and we will likely not know a lot about a majority of the life in our ocean because of climate change. It's sad.
No, you're absolutely right. It is absolutely mind-blowing that it is easier to see into deep space than it is to see into the water that makes up 70% of this planet, right?
So take that, the traveling Wilburys.
Yeah. It's the end of the line. We should definitely have the end of the line in here somewhere.
Actually, we're pretty far away from the end of the line of the story because next up, they're going to try and sequence the entire genome of the Nibblerids and the Nebulids that they have, while also looking for new species within this supergroup. And then they're going to try and 3D model these things. I have trouble. They're so new and weird that it's kind of I have trouble talking about them. These Provora. I guess we'll just call them Provora. So that's next up. So we're far from the end of the line. Who knows? Maybe this line will never end. And maybe the Xenobots will make these like the foot soldiers and their impending army as they start to take over the world via our oceans.
I'm just looking at this picture, and it looks so innocent, but they're just filled with violence.
I mean, frankly, the nebulids are just filled with, like, prey microbes. That's all they're filled with.
Stop the podcast presses. We have major news about nuclear engineering, fusion, and nuclear science. I'm sure everyone's already heard about this historic first, but we got to weigh in on it too here at the Science Night podcast. So, on December 15th, America crowned a new Miss America. Grace Stanke, a nuclear engineering student at the University of Wisconsin, science communicator, and newly crowned Miss America.
Wait, don't we know a nuclear engineer?
Hold on.
From the University of Wisconsin?
Okay, it's me. Grace is amazing. I got to watch it live, and it was one of the most exciting things. We had a watch party / study party during the competition, and it was just
That's awesome.
So exhilarating to sit in a room with people at the university, and we knew her, and to cheer for her, and to watch on the Miss America stage them ask questions to Miss Wisconsin about nuclear fusion. I mean, it was amazing. And then her social initiative was on nuclear science. I just can't believe it. And like watching the rounds of finalists and like her name just kept going through until she was crowned Miss America. It was brilliant.
That's awesome. The kids are all right, man. We're going to be okay.
Yeah.
It was really amazing to watch her and her talent and her way that she communicates nuclear science. So I'm really excited to see what she does now that she has national exposure for this.
Mm-hmm, for sure.
I mean, I don't know a lot about nuclear engineering. I know you've tried, Steffi. I know you've tried, but it's just, there's a lot of skull to get through to my brain. But I am really excited as like a science communication standpoint, just to have like another science communicator in a very prominent role that's going to be making the rounds on your Good Mornings America and Today shows. And I don't know, Good Morning Wisconsin. Do you have a Good Morning Wisconsin?
I mean, we have morning shows. I mean, local news. Another thing that I found amazing was looking at the social media afterwards when they were, announcing who Miss America was and her advocating for nuclear science, and seeing all the parents talk about how their kids were watching it and that was their favorite social impact. And so just seeing that was pretty amazing.
So congratulations to Grace Stanke. We look forward to hearing from you on a future episode of the Science Night podcast. Got to throw it out there into the ether, right?
No.
For
We'll
sure.
go through official channels for sure. Well, as we kind of bask in the glow of a nuclear scientist as Miss America, maybe it's a good time to hear from another podcast that I think you will enjoy.
Nature, we're part of it. Animals, we're one of them. What can we learn from other species? How can our lives be better by reconnecting with nature? And why does it matter at all? That's what Wild Connection, the podcast, is all about. Every week, we bring you authors, filmmakers, scientists, and conservationists whose work is revealing why being connected to nature and wildlife matters. You can find us where you get your podcasts, including iTunes, Google Play, and Spotify. We're hosted by Podbean, so you can find us there too. And you can keep up with us on Twitter at WildConnectPod.
All right, we are back, and like I said, we talked about the major news in U.S. fusion energy that came out last week, the new Miss America, but there was this also, it was kind of like below the fold. So on December 13th, just after I posted our previous episode, which is why we didn't break the news, and instead the U.S. Department of Energy announced that the National Ignition Facility achieved ignition in a fusion experiment for the first time ever. And now, since we have our very own Dr. Deem to tell you exactly what that means, I'm going to let her do it instead of stumbling through it. But I want to approach this story in 3 different ways. So first, we're going to talk about like what ignition is and what this is and what actually happened. And then I want to talk about how the story was covered, because it was kind of wild seeing how this science was communicated to the public for good and bad. And then we'll, talk about like what this means for the future while also teasing our Festival of Fusion 2023. So, Dr. Deem, I am going to give the stage to you.
Okay, I'm first going to cover what happened. When they say ignition, that means it's a very specific set of conditions. So, to first prove or show feasibility of controlled fusion here on Earth, you need to show that you can produce more energy out from fusion reactions than you put into the fuel. Just to the fuel, not the whole system. Okay? We've got to start somewhere. So they prove that and more, because when you reach ignition, it means that the system becomes self-heating and self-sustaining, and you don't have to put any external heating in to heat the fuel to keep it going to fuse together. So that was amazing. Because like I said, we've been charged as a community to prove that we can do this here on Earth, and we finally did it. And that's awesome.
The actual, like how this was actually reported, right?
Okay.
Because it was pretty wild. You had the U.S. Department of Energy's press release, which was standard scientific press release. Although I did like how the secretary of energy, the person who was doing the release was like, by the way, we're hiring. I thought that was a good way to close out the press release, saying like,
oh yeah, I think it was someone from Lawrence Livermore at the end.
Okay.
It was like, we're hiring.
Yeah, I thought that was great though.
Yeah.
Like, by the way, if you want to do a really interesting job in engineering and science, we're hiring.
Yeah.
Which is a good kickoff to like, this is a first step, but not a final step. And then as it made its way through the news cycle, I've seen good attempts at science communication. I've seen some pretty like half-hearted attempts, like, oh, I've been asked this question, so I'm going to talk about it. And then I've seen some like straight up misinformation about what this means. Everything from like, we're a year away from free energy for everybody.
Yep.
And that kind of thing. So what do you think about how this news, which is a major find, but doesn't mean that we're like next year we'll have a fully functioning fusion power plant on the grid, right?
Yeah, so we still have a lot of work to do. So we showed that it's feasible here on Earth to have controlled fusion. Next, you need to do all the work that goes into actually generating electricity. So I think showing that we can, reach ignition really unlocks the next steps and motivates it. We need to develop advanced materials that can withstand these harsh fusion environments. And then we need to do all of the extra work that goes into making the fuel and generating electricity and sustaining it for longer periods of time. Specifically for inertial, because this was laser-based fusion, you have to, do advances to lasers and get the repetition rate up and the efficiency. So still a lot of research that needs to be done, but like science, we're always evolving and learning and understanding, and there's always next steps, but you always have to start from somewhere. What becomes tricky is when you're communicating how we do science, and that science involves a lot of failure and understanding, and sometimes that doesn't come through.
I saw a lot of like interesting if true, because there's still not a lot of trust.
I saw a lot of people focusing on how much energy that they put in to actually generate the laser power and things like that. And I think you're focusing on the wrong thing. That was a science experiment. All of our things that are science experiments are not optimized to generate electricity. So, of course, it's going to take more energy than a power plant will. That's by design. Oftentimes, we're designing these experiments and running them decades later. So you're working with old technology just to prove you can reach those fusion conditions. The other thing is we have a lot of instrumentation that's on the system so we can get a deeper understanding of the physics going on so that we can refine our models that we use to predict the next experiments. That's not going to be in a power plant either. So you have all these non-optimal systems to begin with to give us this deeper understanding so that we can reach these ignition conditions that then lets us, do fusion.
So you talked about how this was a laser. Well, they're calling it a laser shot to start the experiment. Is that correct? Is that accurate?
There are 3 main ways that we're looking at achieving the conditions for fusion here on Earth. They used inertial. It's called inertial fusion, where you focus laser energy to implode the fuel for fusion. I work on magnetic fusion energy, which is creating magnetic bottles to confine the fuel for fusion to heat it up to 10 times hotter than the sun. And then in between, so magnetic can be long pulse, inertial, very short pulses. In between, you can use magneto-inertial. It's like a combination of the two. So that's where that comes into play. It's just different ways. Yep.
You've answered my next question is, how is this different from how you do things at the tokamak? And you just told me because you're an excellent science communicator, and that's why
I don't know about that.
This show.
Oh, I do. I know.
Thank you.
Yeah.
You're welcome.
Confirmed.
Thank you.
Obviously, this has a lot of impact on the future for fusion energy, but like you said, there's a lot of work to do. And I think this is now the opportunity to tease our Festival of Fusion 2023, which will be coming to you in January. So stay tuned for that. We'll talk about this in much more detail because we'll have a whole episode to talk about it. And I'm really excited because I get to learn more things about fusion and become a well-rounded individual. Rounded like a tokamak.
Nice. Well done. I think the biggest thing we learned is that, I guess, fusion energy is 25 years away, right?
Yeah.
No, 23 now. 23.
Right.
23 and me. I know what we've actually learned is there's this big fusion story that I'm given like half of my show to, and I still haven't stood on top of a tokamak. That's what we're learning.
Well,
hey, I'm going to defend Dr. Deem here. You were invited.
Yeah, I invited you.
That's true. Well, stay tuned for more fusion news in January or whenever it comes up because, we're a science communication podcast covering the news. We're going to talk about the news anyway. You've come to the end of another edition of the Science Night podcast, but we got some fun stuff happening in the new year, so follow us on social media and you'll never miss a thing. If you want to follow me, I am on Twitter at James_Reed3. Steffi, where can everybody follow you?
For now, you can follow me on Twitter at Steffi Deem and Instagram at StarShipin.
And Jason, where can everybody follow you?
I am on Twitter at OregonJM.
You can follow the podcast at SciNightPod, and you can visit our home on the web, which is SciNight.com, which has links to all of our social media. And remember, you won't follow us for that top 5 countdown that's coming your way, starting as this episode is going into your ears. And then you also got links to all of our past episodes, the people that we talk to, the things that we talk about, and our merch. You can find it all at SciNight.com. We'll be back in a few weeks. We're taking a little bit of a midwinter break, but we'll be back in January with some new episodes. But until then, have a great night. The Science Night podcast is a proud member of the Riverpower Podcast Mill. To find out more about our shows, go to riverpower.xyz. Do we want to start over? Welcome back to another edition of the Science Night.